Good afternoon. Welcome to, I think it's the fourth session, but I have to admit I'm losing track. The first speaker of this session is Professor Stephen Schneider. Professor Schneider is a professor of biological sciences at Stanford University, where he has been since 1992. His PhD was in mechanical engineering and plasma physics, which was earned in Columbia in 1971. And he spent a substantial portion of his career at the National Center for Atmospheric Research, where he founded the Climate Project and also helped establish or established the interdisciplinary journal called Climatic Change, of which he still serves as editor. He was honored in 1992 with a MacArthur Fellowship for his ability to integrate and interpret the results of global climate research through public lectures, seminars, classroom teaching, environmental assessment committees, media appearances, and on and on. He's written extensively, as many and even perhaps most of you know, on various matters related to climate science. I actually find, I don't know all of his work, but one article in particular caught my attention some years ago, which appeared in Nature, and it's called Earth Systems Engineering and Management. I don't think it's at the center of his interests, but it was a fascinating piece anyway to consider or explore the fundamental new relationship that humankind has with the environment owing to our global scale impact on the atmosphere. The article opens up with this brief paragraph. Imagine that we could let the world's economy continue to grow, bring the disadvantaged classes up from poverty, and at the same time not threaten the atmosphere or global ecosystems with unprecedented buildup of greenhouse gases and the projected climatic risks of such growth. Earth systems engineering and management may be just such a panacea, some have suggested. But could we anticipate the costs or ever truly predict the consequences? I don't know if that's what we're going to hear about today. I commend the article to you, 2001 in Nature, and welcome Stephen Schneider.
Thank you, Bill. Actually, I wish you had told me that before. Then I could have talked about that, because a good fraction of what I was going to say has already been well covered. So I could do what a normally nice person would do, which is to cut my talk in half, but being a professor, it just means that I'll spend more time elaborating on all the other fine points you missed. Or that might not be entirely true either. Anyhow, it's a great honor and a privilege to be here to honor one of my heroes. And a very short art story before we go. I think a year or so ago, at a meeting we had in Aspen on environmental uncertainties in the climate area, Art, I guess you and Terry and I were having lunch, and I said, so think back to the compact fluorescent and the grant you gave to people, which led to the invention of the electronic ballast to make it possible. What was the payback period, since I keep hearing from some of our federal officials that it's too expensive and insufficiently economic for federal investment? And uncharacteristically, he didn't say anything. And we're eating and going through all this, and somewhere about 45 minutes later, as we're about to get up, he looks up and he smiles and he said, return on investment, probably 100,000 to 1. And I said, oh, and how many tons CO2? I don't know, a couple of billion. So there was Art, sorry to have ruined your lunch, sitting there calculating in his head in the proper, this is what your business school should be doing, proper return on investment logic for the $100,000 investment of your taxpayers' money, you know, this rape of our poor taxpayer that Art was responsible for. In fact, he was very fair. He says, no, we shouldn't call it 100,000. We have to weigh in overhead and some of my salary and other things. Let's call it $500,000. Okay, $500,000 for a couple of $100 billion gain. That's not too bad, even over 30 years, even with a 12% per year discount rate. So thanks for that, Art, and a whole bunch of other things. Okay. Now, oh, there's supposed to be a picture here. I'm not very good at these. I'm really impressed that you do your own PowerPoints, right? I can't seem to get mine right. So what was this typical photo op for art? Oh, yeah, that. So you notice the apocryphal strategic lie about cyber incompetence. I am actually a cyber incompetent. Terry Root did this for me last night, or it never would have worked. And the Rosenfeld effect, and the answer to that question is going to be very typical of what I'm going to talk about what is dangerous change and how do you fix it, is it's way too many effects to measure, so we'll give you a probability function. The only good news is that the far left end is still positive. Okay, now speaking of photo ops art, there are several people in this room, and here's Inez, who allowed themselves to be involved in this very nice photo op in our bipartisan world with the Democratic mayor and the Republican governor and the announcement of California's 80% cut. How come you weren't there? They're only using your numbers. Couldn't figure out. He's probably too busy being back at the lab, shutting out lights in the middle of the day, and missed the big chance. In any case, California has been a leader, and one of the easiest things to do, I'm in Australia now and trying to help convince a lot of people there to adopt the California standards, is it's so much less threatening to go to a place and not discuss their coal issues and their inefficiencies, but to say what we did here and how that helped, and then by analogy you can bring people around without defensiveness. So we owe a lot of that to you. Okay, on to the dangerous thing. Munich Re, rather large company. You add up all the reinsurance companies and they're $1 trillion worth, just like some big fossil fuel companies. So the industrial monolith that had for many years opposed any real substantial government involvement in the, quote, free market, as they said, no longer is a monolith. Not only do we have large companies like that, and Evan Mills can tell you the numbers, but they're already out there. This was the president saying, or the CEO, we have to stop this dangerous experiment humankind is conducting on the Earth's atmosphere, referring to emissions of greenhouse gases. But of course, what does it really mean? Well, we can always turn to the law, and this was already mentioned this morning, the United Nations Framework Convention on Climate Change, so I don't have to repeat it other than remind us it's stabilization of greenhouse gases at a level to prevent, there it is again, dangerous anthropogenic interference. It recognized that time mattered. I would personally say I would rather have 3 degrees warming in 200 years, not that I want it, than 50 degrees, I'm sorry, I wouldn't want 50, than 2 degrees in 50 years. Because the capacity of nature and us to adapt depends upon the ability for a whole series of interconnected elements operating on different timescales to move around, and for us to have the ability to forecast and respond. So rates matter, and the diplomats actually got that right. They had ecosystems, food production, and development. It was also mentioned that this was signed by Bush 1 and ratified by the U.S. Senate. I think that there are about 190 countries, I've forgotten the number, of which this is now the law of the land. It's our land and other people's lands. And I always wondered whether the egregious violation of fundamental laws characterizes high crimes and misdemeanors. I think that the Senate ought to take that up in connection with, say, the West Wing. Okay, dangerous climate change. So the first question is, who decides what is dangerous? And I will address that. I guess the short answer is, you do, when you make decisions on how you're going to live your lives, what cars you buy, what health styles you have, and what you think is acceptable in terms of what organizations you write your campaign contributions to, the products you buy, and the leaders you support. And it can be corporate scale, it can be local government, state government, national governments, and even international. So the decision is made by a wide range of stakeholders, governments, and different sectors at different scales. Now that's not going to be a simple aggregation into a world political decision, particularly when the world has no formal and legal political organization other than when a lot of countries agree to a treaty that doesn't have any enforcement in it. Okay, so there's many ways to define DAI, dangerous anthropogenic interference, which is the acronym that we now all use for this. And ultimately, it's not a scientific choice because, in fact, I'll tell you the story of my own penance in this area. When the 100 or so governments that direct the IPCC, the Intergovernmental Panel on Climate Change, and give us our marching orders and review the documents and approve word by word the summary for policymakers and accept the big long chapters came along, they said, okay, the UN Framework Convention defined it, announced it, now you're the scientists, you define what is dangerous. So of course, we being typical scientists turned around and said, oh, no, we can't tell you what's dangerous. That's an acceptability judgment. That's your job. So this kicked around between we're supposed to do it, but we scientists don't make subjective personal judgments, and then they wanted to have us to blame for what they did. So where we reached an agreement so far, and I'm the convening lead author of the chapter of the current Working Group 2 in the current assessment, which is called Key Vulnerabilities and the Risks of Climate Change, basically the science of Article 2, what is dangerous. And the compromise that so far has flown through the various governments, and we'll see what happens in our plenary next year, is that the job of scientists is to define risk, what can happen and what are the odds, and then the job of decision makers at every scale and in every entity is to choose acceptability, what's fair, what's effective, and what's affordable, and what's unacceptable in terms of thresholds that you might transgress. So far, we're holding this coalition together, but there are so many sectors, so many stakeholders, so many different views that it's very difficult, let's go back to that business school question, it's very difficult to do an aggregation in terms of the single numeraire of dollars of things traded in markets discounted at the return on investment for the average competitive investment. In fact, that paradigm of decision making that may be predominant inside of our Office of Management and Budget in some OECD places is viewed by at least 80% of the countries I've observed at the international negotiations as a fundamentally unethical paradigm because it doesn't recognize the distributional inequities associated either with who produced the problem or who has the capacity to adapt. So you end up like the Los Angeles freeways, right? You get these intersecting roads and there are these 7 lanes, and then the one going left goes up at 100 feet, and then the one going right goes up at 180 feet, and then one in the other direction goes up at 200 feet, another one 250. They never meet. Nobody ever, thank goodness, we hope. And then they all go separately. Well, when you go to an international meeting and people are arguing about what to do about climate, they're all citing out-of-context components of the scientific arguments from different ends of the spectrum of possibilities. In the next talk, we'll talk about that issue, so I won't go into the media components. And then they have absolutely different frameworks as to what constitutes an ethical judgment. And they talk past each other because they're living within a blinded paradigm of decision-making as cash flow transactions of aggregated dollars of things discernible and detectable and measured in the market. And other people are saying, oh, well, how does it affect the poorest people in the world who had least to do with it? And their whole decision paradigms are radically different. And as a result of that, their capacity to reach agreements are difficult. And as we heard from at least half a dozen previous speakers, we have to solve this problem through some kind of collective action, though it doesn't require everybody to doing equal things at once. It certainly requires all of us eventually to do something. As a result of that, step one is to understand where that other person's thinking comes from and how they see the world so that you can at least achieve minimum initial level of cooperation. And that's why the fact that the international process has been going on about 20 years now, my students say, aren't you frustrated to death? I guess the answer is, yeah, I am. But in truth, in a generation, we've made a fair amount of progress. We're moving along way too slowly relative to what we need. We can't prevent some preventable damage, but we can certainly maybe keep it under 3 and not at 6. And there's a hell of a difference between 3 and 6 because damages are very nonlinear. So therefore, we should never have the false notion that if we don't meet our precise target, we failed. The object is to make certain we keep reducing. And by reducing, I do not mean deceptions like the West Wing plan to improve carbon intensity. What was the number, John? 12% over a decade? What? 18%, which was, I believe, precisely what it had done in the previous decade by the structural transformations. Not even as good. All right. So the point was, this was ice in Antarctica, and I don't mean West Antarctica. That's melting. I mean ice in the center. So they were selling us the normal progress of the economy and calling it a policy. And where was the media? That's the next talk. Okay. So it's not a scientific choice. One other factor to really exemplify that. So this is, don't read the whole thing. This is a headline I recently got. So the Inuits are accusing Washington, the melting of the Arctic ice, which is documented, of violating their human rights by fueling global warming, that is not following the UN Framework Convention treaty that's the law of the land. And the question is, think like a cost-benefit economist. You'd say, all right, let's look at the Arctic. What's going to happen there? Well, on the bad side, it's not good news for polar bear ecosystem. Everybody admits that. Of course, we don't know what they represent GDP-wise. I suppose you could use the travel method and figure out, how many millions would be lost by not having people go there. But it's not going to be big money. What about the Inuits? Well, the ice is going to recede from the coast. That destroys their culture. Well, this is certainly dangerous to culture, but is it going to kill anyone? I'm sure our vice president would think, and probably has said, that they're better off. They can just simply be oil rig operators in Anwar. I mean, they'll be making more money. Isn't that a measure of benefit? I mean, and then we know that the shipping industry is going to have shorter routes, and you can measure that both in dollars and in tons of CO2. So you can run an aggregate cost-benefit analysis and say it's positive, let's melt the sea ice. Or you might say, wait a minute, what fraction of this problem was created by these Inuits? What's their capacity to do it? And who said that, that one or two generations of people who have other alternatives that they chose not to have or were politically blocked from having should just simply say, we're now going to aggregate all the dollars in a $1, one vote aggregate cost-benefit analysis as if somehow that was fair and equitable. And most of the people in the world, as I said, do not make decisions based on aggregating market-traded dollars. That's a very, very American-oriented thing. And you wonder why we're so well loved at these international meetings. Okay. All of that having to be said, science hat back on, you will hear there's a lot of uncertainty in this problem. You will also hear people saying the science is settled. No, the science is not settled. What is settled is that it's highly likely to change within certain ranges. It's highly unlikely to be outside of them, but you can't even rule that out at a few percentage points. And that while we know for certain that there's warming, we know almost for certain that we have something to do with it. Precisely what will happen in the distribution of temperatures, we have a good idea, not perfect. And what happens to the distribution of precipitation, we're kind of blue skying. And therefore, what happens in the public debate, and again, next talk will go on this, is that you take the stuff that's relatively speculative, uncertain, and then you conflate it with the stuff that's well established, and you convey the impression that nobody knows anything. You say, therefore, we shouldn't do anything. And that's the problem. How do you deal with uncertainty? You cannot lie and say it doesn't exist. I don't find that okay. And at the same time, you can't say, well, we have uncertainty, therefore we don't act. I'm certain there was no uncertainty in the decision having to do with that high-quality information about WMD in Iraq. Okay. Best guess. That's what we used to do. Analytically, we started out with best guess, medians, exactly what cost-benefit analysis does. Pick a number, and now you have a number for costs, number for benefits. You have a discount rate. You can run an optimization and come up with a carbon tax of $4.74. And believe me, the literature's filled with that stuff, with 2 and 3 decimal point precise numbers. I don't know the sign, but they know it to 2 decimal points. And that's what happens when you pick best guess in a world in which all the major parameters are relatively uncertain, though you know where the center of the range is. So we got smart and we went to ranges, better than that, and that's certainly fair, but what we really need to do is PDFs. Now, Rob, I think you were saying it's kind of hard to sell anything beyond the area of a triangle. Now you go Congress and you start selling PDFs. Now that's a real easy sale. Everybody there knows what a PDF is. I mean, they say, that's been invented. I said, no, sorry guys, I mean one of these. I mean one of these bell curves. So now, these are real numbers. So if they're real numbers, I got to tell you how I got there, and we don't have time for me to tell you all of that. But this is, what this represents, Mike Massandrea, my postdoc and I did this. There's an entire family of literature which gives you the sensitivity of the climate to forcing. By that it means if you doubled CO2, about 4 watts of energy over every square meter, held it fixed for a long time, couple of 100 years, you'd warm up by X. That's called the climate sensitivity. It's typically in the 1 to 4 or 5 degree range, with some probability being above and below it. So what this was a particular scenario of greenhouse gas injections. I think this was about 2.5 times pre-industrial at the end of the century. This is in 2100, should have said that. And what you're really looking at there is the uncertainty in the internal dynamics of the climate models, not the fan of uncertainty associated with human behavior or policies. So just look at it. What's the 10th percentile? You're all numerates, you know, somewhere in here. That means you've got a 10% chance of somewhat less than 1 degree additional warming on top of the 8/10 John said we had. Let's go out to this end. Oh, that means there's a 90% chance it's less than 4, but 10% chance, even more than 4, getting up to the ice age interglacial cycle transition differences. And of course, I don't hesitate to say that's catastrophic. Even at 0, which is above present, we're starting to have evidences in stronger hurricanes and bushfires, heat waves in Europe. So it's already too late to escape scot-free, and that means at best maybe 10 percentile says that you're just doubling what's there, and there's a much higher probability it's going to be worse than that. So with that, you show this graph. So there's an economist in the room at the time I first showed this a couple of years ago, and he said, wait a minute, Schneider, you mean to tell me that you want us to redirect the basis for industrial civilization, deny the developing world their chance to play catch-up from our Victorian Industrial Revolution when there's only a 10% chance of really, truly catastrophic outcomes? And we were eating salmon that night, and I said, Joe, actually I think his name was Bill, but I don't want to give anything away. I said, Joe, there's only a 10% chance of salmonella in your salmon, so of course you're going to eat it. And there's only a 10% chance the rivets are going to pop off the airplanes, I think one of John's favorites for God. And when did we use that against Lovelock in 1974? You know, we're going to pop off the airplane of the, when you fly home tomorrow, so of course you're going to do it. And, oh, I did then what I'll do with this group. So how many people here have had a fire in your house? 7, 8. Oh, that's right, it's Berkeley. That's why it's higher than normal. I forgot. Okay, this is usually about half that. How many people have fire insurance? Fools. I mean, it's less than 10%. I mean, I can't believe this. I mean, after all, we have way too much uncertainty to have any public policy action. So somebody else says, you got any other analogies? I said, well, you know, imagine, 747 landed with 500 people on it. So which 50 are you going to break their arms and their legs or shoot them or something else? That's 10%. I said, we consider it unacceptable to have risks much more than 1 in 1,000, 1 in 10,000, except certain risks. Therefore, we're talking about risk management. We are not talking about precise probabilities, nor are they necessary. We have to then talk about in how to fix the problem, what are the ordered set of steps that, like an economist, I'm going to think now, in a supply curve, you start out with fix the stuff which you should have fixed even without climate change, efficiency being one of the big ones, and you get extra bump on climate. Then move toward the middle level stuff, use the diamond lanes and get the subsidies away from the Hummers, and then announce real shadow prices on carbon, because we're never going to get anywhere near a 60% cut by the middle of the century by pretending that we can dump our waste in the atmosphere as if it's a free sewer, as some protection of a mythical free market that hasn't existed for a long time, because every time that junk is up there and it sends one of your kids to the hospital in asthma, or a senior person, in with some other lung disease, to say nothing of the increased hurricane intensities and other risks, that is a subsidy to the status quo. It has nothing to do with the free market. That needs to be taught in business schools as well as in economics departments. By the way, it also needs to be taught to my biological colleagues, too. So we in the disciplinary world are a little bit guilty of not being too knowledgeable about sustainability science basics, and that's also part of it. We better look in the mirror and not just say somebody else is responsible. So let me end. I'll move toward ending. So climate policy is a risk management question. That is not unfamiliar in security investments and security planning, it's not unfamiliar in medicine, and it's not unfamiliar in business. This is not radical stuff. What we're talking about is a different scale. It's a collective scale. It's about threats to the life support system of the Earth, or even if not to the whole support system, to very important elements like species that co-evolved with climate over 100 million years. And now one generation comes along, and as I said, hell-bent on doubling its numbers and times 10-tupling its economy, and unwilling to spend 1% of the GDP, which would delay us by about 1 year in being 500% per capita richer in 2100, to work with the problem. And it's what I call the Carl Sagan effect. Remember Carl? And he used to get made fun of by Johnny Carson for his millions and billions and trillions. Well, that's just what these guys are doing. They're going out there and they're saying, oh, well, the cost of mitigation of these outrageously expensive things could be measured in the present value of $10 trillion. Now, never mind they left out no regrets, never mind the high discount rates. Let's buy everything in the neoclassical economic model. If it's true that there's a $20 trillion present value and it's about a 1% loss in GDP 100 years from now, to have very stringent climate policy, $400 a ton carbon taxes, which would really change the market and bring about a lot of your wedges, though not immediately. It would take a generation or two, as we heard. But if this happened, so we hear from the economic rationalists that that is denying our posterity a legacy of wealth and infrastructure because we, quote, wasted the money on this problem that we're not sure is going to be that severe. Well, just exactly how much is that insurance premium? And if it's truly 1% lost in the economy, let's measure it against the average growth rate in the economy, 2% per year, roughly. So at 2% per year, that's a 35-year doubling time. So in 100 years, that's 3 doublings. 2 to the power 3 last time I checked was something like 8. I'd never asked that question in the West Wing because I wouldn't, want that those addled brains to have to figure it out. But in any case, so it's a factor of 8. So if we have a $40, $50 trillion economy now, we have a $400 trillion economy then, sure, 1%, that's real money, $4 trillion just in 1 year. That's what? 40% of the current U.S. economy, something like that, something absolutely and completely unacceptable. I agree. It would be unacceptable to me to have that kind of a hit in the economy. But that $4 trillion is 100 years from now. It's not now. So the problem is you get this distortion where people use aggregate numbers. Now, what I've asked my economist friends who use those numbers and others is, you want to give me the present value of consumption discounted over that period? It's probably 100 times larger than those costs. So what we're talking about is, if you have a 2% per year growth rate on that economy, right, a $400 trillion economy, so that means in 1 year you're going to get $8 trillion back. So the insurance policy is being 500% richer somewhere around July of 2100 instead of January to have climate policy. It's a lot of absolute dollars. This is not a macroeconomics problem. Don't let anybody fool you into thinking it is. What it is it's an equity problem. Not just the equity of who dumped it in the atmosphere and who pays, but even if we could show macroeconomically that there was all these no regrets and the win-wins, it's not going to be a win-win for most coal miners. It's not going to be a win-win for people who make SUVs and Hummers. And I don't personally believe them to be evil people. They're not doing this for the purpose of putting junk up in the atmosphere to hurt the climate. They happen to be in an industry that we have to put some constraints on, but we need to deal with soft landings, and we need to deal with what the good economists call equity side payments. If you want things to happen politically, it isn't simply doing the macroeconomically right thing. You also have to take a look at blocking coalitions. That equally applies to poor people who drive inefficient cars, who have long distances to commute because the way we've set up work and living, and because they don't have access to those cars. And I've never believed that you subsidize poverty with artificially low prices of commodities like food and energy. You subsidize it with the real stuff, money. So how would you do money in this case? How about a $5,000 voucher to somebody who's documented below income, or do it on a sliding scale that they can use to buy only a better than 40-mile-a-gallon car in the market? You could even double it if they bought it in Detroit. I mean, do something to set up incentives that deal with fairness and effectiveness at the same time. So the how to fix it, to me, is a whole package of things which fit together that deal with some immediate plug the holes, efficiency starts, but then we also have to realize that we don't just step to the back of the room and look at macroeconomy. We have to look at distributions, we have to look at who's hurt, and we have to try to set up some kind of soft landings for them in order to have it work. Thank you very much.
Questions? One here.
Nehemiah Stone with the Heshong Mahone Group. Near the beginning of your talk, you mentioned the process of figuring out who makes the decision about what's dangerous. And there was an implied question there that you didn't really go into, which is who should make the decision about what's dangerous. And in a way, you kind of circled back to that at the end in talking about equity, but you still seemed, in my mind, to avoid it. It seems like who should make that decision is the generation that has to live with the results. In the work that you're doing with these groups internationally, are you talking about equity generationally as well as rich country, poor country?
Yes, thank you for that. The problem is multiple. It's that you have multiple constituencies. You have to have a time rate of preference. I love questions. Let me finish my talk, but I can't really do that. It'll take too long. But I could show you a couple of things. We've seen this before.
We need the projector back.
Oh, okay. Well, I was going to say you've seen before similar things. So this is the IPCC projection. So there's the fossil-intensive world where CO2 triples at the end of the century, and you can warm up as high as 6, 7 degrees. This is the world of egalitarian sharing of new technologies distributed, the so-called B1 world. This is a world where you spend 1% of GDP on technologies. The best of these two, this is emissions. This is not concentrations. There's still CO2 doubling over pre-industrial. The best scenarios in IPCC are doubling. Everything we do is worse than that. I'm coming to your question. So now, what I argued and what I honestly believe, John Holdren tried his best to put the happy face this morning when somebody said, are we going to be over 2 degrees? Well, maybe 20% we won't. I agree, John. It's not a very happy picture. So there's some scenarios that your colleague, Mike Oppenheimer, has published at Princeton, Rob, and it shows two stabilizations, 500 and 600. Now I'll address your equity in a minute. So there's a slow rate and there's a fast rate to the 500. Here's a slow rate and a fast rate to the 600. What's that? Those are two overshoot scenarios. Those are things that we hate to publish, but we are, after all, honest analysts, and we don't really see much prospect for doing too much better than one of those. So what we asked, and this is what I'll end with to try to get your question, is if you have an overshoot, and then you come back down, which is what we're hoping will happen. So the fossil fuel, just sort of a really hysterical, century-long, wild binge of this particular species. Then we get over it, we get mature, and we get out of it. What's irreversible? Well, melted Western Arctic ice sheet would be essentially irreversible. Species extinction is essentially irreversible. And if they're proportional to certain temperature thresholds, the lower you are and the slower it takes to get there, the lower the number of those kinds of irreversibilities that are going to occur. So if you're really looking, so here's the dangerous threshold. This is just illustrative. So with an overshoot, you're going to have a mean exceedance amplitude, and you're going to have an integral. You're going to have the number of degree years. And therefore, you can't just, and this is the last one I'll do in this, you can't just say, well, in the long run, overshoot's okay because we're coming back down to a relatively good thing. This is a threshold for dangerous. This is the EU. This is 2 degrees, John, above pre-industrial. This is above present. And if you ask what's the probability of exceeding that in the slow-changing world, it's still something like 45%. And what is it if you look at the maximum amplitude of the exceedance? It's something like 77. So you're taking a heck of a lot more risks, but it's still better than going on and on and on up to the tripling and quadrupling and beyond. So what we have to do when we say what to do is let's get started as fast as we can. Should have started 25, 30 years ago, Art, when a lot of us were talking about this, a lot in this room, and move it down as fast as we can, deal with the equity side payments, and recognize this a piece of the sustainability debate. And there's no one-size-fits-all. Start a lot of ways. I mean, Bush 1, who signed that other thing, he had one sentence, I don't like quoting Bush's, but this one I will, when he said, let 1,000 flowers bloom. We don't know which ones are going to survive intact. We've got to go through the game. So let's just do a lot of things, and let's try a lot of things, look for cost-effective and fair along the way, and then adjust the knobs as we learn more. But we still have to deal with that side payment issue along the way, and we'll never get anybody to agree to it.
We have time for one more question.
Dave Hafmeister, Stanford University. A couple weeks ago, there was a NOVA program entitled, a pessimistic program entitled The Dimming Sun. And it really wasn't that the sun was dimming, but that there was
Aerosols.
a bigger term reflecting out aerosols. And Jim Henson and so forth were saying this was going to have a much bigger effect. You had, you know, the net effect of climate change or carbon dioxide would be much larger because we underestimated the reflection. What do you think of that?
Okay, that's, oh boy, I'm going to do that quickly. I started my career looking at whether aerosols, the particles, you know, suspended in the atmosphere, reflecting away and cooling the Earth, were going to be more or less significant than greenhouse gases. Our preliminary calculations said the aerosols were, and we were going to cool. I have to listen to George Will say I'm an environmentalist for all temperatures now. I happen to have found out what was wrong with it. What was wrong with it was that they're not global, that they're regional, and there's also embedded soot, which actually warms, and there are other complicated factors. Aerosols are significant, but we are very uncertain. There's about a factor of 5 uncertainty in how much forcing they bring about. So the fact that there's a reduction of sunlight at the ground does not necessarily mean that it's going to make it cooler. It all depends, because if you're depositing the heat in the middle of the atmosphere and it's heating up there, the ground would have, if it would have been warm enough to create convection, would have just convected it up anyway. So you have to look at what it does to the overall reflectivity of the Earth. So if there's soot in there and gets in clouds and makes them darker, it's going to make the Earth warmer. If it's other kinds of aerosols cooler, it's a very complex mess. And it's one of the reasons why there's this factor of 3 uncertainty in climate sensitivity. It's because you can't go backwards for the last 50 years, run your computer model with scenarios of how much greenhouse gas and aerosol forcing you had, and then get a best fit to what happened. We do that, but we don't know the aerosol forcing to factor of 3 to 4. As a result of that, it still leaves you anywhere from 1 to 5 degrees warming as a CO2 climate sensitivity. And it's a real problem, and whether or not it was worse than we thought, which means that as we clean up the atmosphere because of health reasons and acid rain, we then get a super greenhouse gas emission, or whether or not we overestimate it, I don't know, and that just remains part of the risk management equation.
We will take one more, Mark.
Steve, I want to go back to the issue of what is a minimally acceptable level of emissions. And your comment on different groups having different reactions, coal miners would react differently from auto workers, for example, right, et cetera. And indeed, different governments are going to react differently. And that leads me to the following thought. I wonder if the IPCC isn't the only international body that exists with the expertise to evaluate the situation and the ability to represent every major government in the country. I've been part of the IPCC now. This is the 3rd 5-year stint in prison that I've done with them, and have occasionally asked people who are participants, this is Working Group 3, their view of what would be acceptable. And I think one might get a consensus out of this group, and some key countries who disagree with that consensus. But in fact, I think it might say something like 450 would be acceptable, but probably not achievable. 550 might be achievable, and above that, and we're really in trouble. Now, if that were the case, and if this is the only body who really could say something that might be meaningful on this subject, is that worth pursuing?
Well, certainly I don't consider a 45% chance of exceedance as acceptable. But now you asked me to make a value judgment about how I weigh that versus all the quote-unquote benefits of the conventional development path. And that's exactly what governments and individuals and corporations have to do. If IPCC went so far as to suggest, even if it clearly labeled it as personal value judgments of the authors, that would be called policy prescriptive. It would have zero chance of getting through the plenary, and it would destroy the credibility of the operation. So the only way you can do it is sort of through the back door, which is which literature you select. And even if you try to game the system, you won't get away with it, because I just have this weekend to work on 1,067 reviewer comments, which range from the chapters wildly exaggerating to the chapter wildly understated the seriousness. You know, and you've got to answer every one of them and justify it to 3 review editors. So there's not going to be any personal value gaming. You just basically have to cite in the literature all those things. Where would be derelict would be if in the process of citing the ranges of scenarios, we left out the opinions of some groups because we didn't believe them. I think that would be inappropriate. We have to cite wide ranges. We can also cite what we believe in our assessment to be the credibility of their arguments. But the actual selection of how to make the value judgments, we have to be scrupulously careful to avoid for credibility, as well as for the fact that as individuals we'll do it. I will publish what I believe to be acceptable, and I'll talk about it in Congress. I don't believe I hang my citizenship up at the door of the hearing room when I walk in, but I always label it as a personal value judgment, whether it's quoted that way in the press. That's all we can do, but we've got to examine the range. We are, and we'll see what the governments do at the plenary.
Thank you very much. So one small organizational announcement, and that is that we're going to skip the advertised break and just plow through. And so people who feel an interest or an obligation to relieve themselves or otherwise take care of some business will have to do so while we proceed. It's the judgment of some key people in the front row that we're better off doing that than really cutting off the really extraordinary discussion. So with that, let me introduce the next speaker of this session, Henry Kelly. Henry's another recovering physicist, having earned his PhD at Harvard, and he, in contrast to many of the speakers today, hasn't worked inside of academia, but rather for most of his career in government or non-governmental organizations. So he's worked for the Arms Control and Disarmament Agency. He was the assistant director for the Solar Energy Research Institute. He was a senior associate at the Congressional Office of Technology Assessment, the assistant director for technology in the White House Office of Science and Technology, and since 2001, he has been president of the Federation of American Scientists. And you can see the title of his presentation is about how to get all of our scientific information into public practice, politics of, and energy policy. Henry.
Well, thank you. I'm here from Washington, so I'm going to try to make you feel really good. And anybody who's heard the presentation so far and comes away with the impression that we're not really facing one of the most dangerous challenges that the species has faced has just not been paying attention. But the dilemma here is that the apparatus in place to actually respond to this is in deep disarray. And so what I am going to argue here first is to say that, in fact, the political environment in which we need to make these difficult decisions is not working well. Second, to argue that the piece of this discussion that often gets overlooked is that the decisions here are, the challenges are as much political challenges as they are technology challenges. If you get the incentives right, there are a lot of good ideas that can come out. Third is that if we're actually going to accomplish anything, we have to rebuild an apparatus of scientific policy advice. But then I would try to conclude on an upbeat, because I think that we really do have a unique opening, and the next 3 years really are going to be crucial about whether the U.S. is going to be able to restore its leadership. And shame on us if we don't take advantage of that. So here is the immediate reality check from Washington. We're saying we're facing a great crisis, a national crisis, but our response to it is by cutting the budget in exactly the fields. We have a program here that is focused on innovation that was both talked about by the Congress and in the State of the Union, but the net effect is to actually cut R&D funding. This is the reality. Now, this is partly my diagram of the Rosenfeld effect, and so some interesting things happen. I should say this is the blue line here is the outlays for energy, what the OMB calls energy conservation. Now, this is a maddeningly difficult thing to try to plot because categories keep on changing. But basically, the most visible effect of the Rosenfeld effect is to go from absolutely no interest in efficiency to making it a huge national priority over a very short period of time. And basically, the discoveries here by a bunch of scientists who really figured out what was going on had a massive and important effect, which was largely independent of politics. This was widely accepted. But then you, of course, have a colossal decline. Now, Art actually arrived in Washington around here, so you can see we're back in there. There was he ran into Newt Gingrich here. There was a problem. And here is where he went back to California. So you can see there's a very, very strong correlation here between Rosenfeld. But you do see that over here you have this very odd disconnect. For the first time in history, we really seem to be getting a very strong signal we should be doing something, and the response, instead of being positive, is actually negative. So there's something really uniquely wrong here. Now, I guess my statement here of the Rosenfeld effect, and everybody's tried to state it, is there are two key parts of it. One of it is what happened there at the beginning, and there are a lot of other people here who share this, but Rosenfeld came into the energy problem knowing nothing about it and did what physicists do really well. They asked really simple, dumb questions. You know, why doesn't the moon fall? Art said, where does all that energy go? Do we, you know, what are we using it for? If your object is to have cold beer, what's the cheapest way of getting cold beer? Is it to run more power plants or a more efficient refrigerator? You know, really, really basic questions. Very elegant, simple questions leading to some of the most spectacular progress in this field. But the second part of the Rosenfeld effect is that if you look at what John Holdren said is the biggest barrier to energy efficiency, which is the lack of smart people, I think that to me, the key thing about Rosenfeld is that he fundamentally doesn't believe that. He may believe there are misinformed people. He may think that there are misled people. But he fundamentally believes that if you sit down and talk to people and explain what's going on, and you have a sensible approach, that reasonable people will come around. So the burden of my talk here really is that without that Rosenfeld effect, without both pieces of that, namely getting scientists involved deeply into the policy matter, and an ability to actually talk and communicate and deal in the political process in a realistic way, we're not going to ever solve the problem we're facing. And we had a brief discussion just a minute ago about how do you set values. Well, you know, how do you get science and values? Well, that's what politics is about. When it works right, you have the technical people bringing the facts to the table. You have people with values. You beat each other up. It's open. It's combative. It's ugly. But you know, eventually you do manage to sort out values and facts in a sensible way. Now, the problem that I'm concerned about is that exact process is under tremendous threat in Washington at the moment. And one of the reasons that there is sort of a break between policy and reality is the fact that it has become increasingly difficult to get sound technical advice into the process. And there's been a lot of criticism, but it falls into a variety of categories. One is just flat suppression of information and secret proceedings. The second is the kinds of advisory committees we formerly had in place that provided this kind of advice are rapidly disappearing. And just a couple of weeks ago, the long-standing Energy Advisory Committee to the Secretary of Energy was just abolished with the view that advice could be had from the White House, what did you need the scientists? And there's been concern about people who try to complain about the system from the inside being punished, and a concern, to me, the most fundamental concern, being that there's a conscious effort to create uncertainty in areas where it really doesn't exist. So it's not accidental that you find places where you have uncertainty. And one of the results of this is this bizarre anomaly of the U.S. being one of the few places where it has the highest number of climate doubters in the planet. Not by accident, and I really enjoyed Senator Inhofe's reaction to the National Academy study, in which he said, how can you believe this study? It uses the word uncertainty 235 times. Well, you know, you can, if you can take that and make it into political traction, all you need to do is undermine the credibility of the science and the dilemma here is that if the press and other people allow a few people who can simply challenge the science to be equated to the mainstream science, then you've actually accomplished your goal. You don't actually have to prove that you're right. You just have to undermine the analysis. Now, the problem they face in trying to do that is that scientists, particularly university scientists, have about the highest credibility of any group that was exposed to the public. This is really extraordinary. And of course, one of the troubles with science is that, with climate science, is that instead of seeing real immediate effects that you can prove, I mean, there are always disputes about whether a hurricane was or wasn't a climate effect. You have to believe the scientists, because the scientists, these are calculations and forecasts and analysis. Now, the fact is, though, the good news is that the scientists actually have a heck of a lot of credibility, ahead of major newspapers, fortunately way ahead of Bill Riley, though I'm sad to see that Jon Stewart is at the bottom of the list here. But the challenge we've got, of course, is there's an effort to make science look like just another interest group. So you have all these scientists who, they have their interests, they're trying to get funding for their research. They're just like any other interest group. There's nothing to distinguish them from, fat Americans for SUVs. They're just another another category. Well, the trap here, of course, is to make sure that we really honor that respect. And I think that Steve's response to this question about how do you do values is exactly the correct one. The scientists need to behave as, make sure that what they know and what they don't know is clearly understood. Not to say that they leave their ethics aside, but when they're talking about ethics or values, they clearly point it out. And that's something that can be done. So the question is then, if we're going to solve this political problem, how do we do it? What are the practical steps? And do we have actually the public's permission? Do they want to solve it? So I'm going to talk about 4 specific things. One is that we've really got to work hard to rebuild an infrastructure for providing science advice that has worked for many, many years, but is now in serious disarray. The second is that we do have really serious work over the past few years, centered largely in California, that we can build on, so we're not starting from scratch. The third is that if we have to make this an election issue so that candidates take it seriously, and to do that, we can't talk about the issues that matter to us without thinking about what it is that the public is actually interested in. It's not to say that we're going to mislead, but if there are things that actually have traction in the public debate, we need to understand how it is that we can contribute to that debate. Now, because politicians, of course, pay a lot of attention to the polls and what's hot. Now, climate is not hot. It's not one of the voting issues. And one of the things that people have tried to do, and I hope Joe Rome will tell us more about this, is to say we have an obligation to make it an issue. Now, it's something that no politician has the luxury of being able to do, because you can only respond to things that people care about. It's very hard for a politician running for office to say, here's an issue you haven't thought much about and you should. That's tough. But so there is a significant effort underway right now to make this intergenerational issue a real one. It's a heavy lift. So let me start with the first one, which is to say, what do we have to do to rebuild the apparatus of public policy advice for science. At the moment, if you look at what's in place, there are a bunch of congressional, if you look at problems in Congress, and I must say that the problems are pretty diverse here, but the Congress has actually hollowed out its own advice, particularly on science. The destruction of OTA was really a sad event, and it took some of the best science policy advisors out of the congressional realm. There are hearings which were, at one point, were really thoughtful debates, which really built a record, where the hearing record itself was kind of a record of the information you needed. That's by far the exception, and sadly, one of the few people that really did this right was Shelley Bullard, who was the chairman of the House Science Committee, who is retiring. And that's going to be a tremendous loss, because he was sort of the emblem of how you can actually do this reasonably correctly. So the fact is that most staff members are Googling things. I get random calls from somebody that found something on my website. It really is a pathetically haphazard process at the moment. Now, the administration, the Office of Science and Technology Policy is on life support. It has not been active in these key areas. It has an advisory group which has the power to really produce powerful and influential reports, which it has in the past, and John Holder and others have referred to some of the conclusions of these studies. These things are not coming out anymore. Now, what's been left here is the national academies, which have picked up, filled a lot of these holes. And the real question is this, can they fulfill all of these former activities that were, and the answer is no. The other is to try to, the other source of information, of course, is the press, organizations like mine, and interest groups. But often it's a very difficult, and of course these groups do their best, but again, it's not really a substitute for having a formal process that's embedded in these larger administration. So in the administration, you need to find a way that the president can actually get private advice, but also get a more formal public advice from open advisory groups. And so one of the things that we have been suggesting is that you really need to formalize, you need to make the National Science and Technology Council, give it the kind of status that the National Security Council has, which is to say a permanent staff. Right now, OSTP's staff is essentially completely laid off. You need to have an advisory group that has the status of the National Science Board at the NSF, which has got 6-year terms that stays without regard to what the administration is. That worked very successfully when it was initially launched, actually. The thought was that the National Science Board would provide science advice across the entire government. In fact, it's only now, unfortunately, advising the National Science Foundation. Now, the problem of federal advisory committees, one of the problems, of course, is a lot of these are simply being abolished, and the ones that are intact often have people of dubious backgrounds appointed to them. And there have been a number of studies by the Academy and others about how to fix this, including trying to find a way of vetting these. One idea was to do the kinds of things that lawyers used to do before you put appointments to the Supreme Court, a process which, of course, is not, has kind of broken down. But there are ways of trying to, making this a more systematic process. Now, the question about Congress is even deeper. How is it that Congress can actually formulate policies by having a bunch of staff members calling up their friends? The people, the fact is that they're not in a position to argue substantively with a lot of the administration's positions, because they just don't have a staff to do it. And so it's a problem that needs structural repair. This is something that elections are not going to fix, and you really do need to find some way to reestablish something that provides systematic technology advice like OTA used to do. Probably restarting OTA won't work, putting it in GAO or something may. Now, interestingly, one of the most powerful sources of science advice to the Congress has been fellows provided by the Congress, by MacArthur and other, the AAAS, by the American Physical Society and so on. That's been an enormously powerful tool and should be continued. MacArthur has actually decided that they're so distressed by the lack of science policy that they actually paid to set up their own national security policy group focusing on Congress. It's kind of odd that they're doing that. They're actually set up one to provide science advice to the State Department. It's kind of bizarre that you're sort of privatizing science advice. But in a pinch, it may be all that we've got. Now, another problem that I won't touch on in great detail is that the ability to do public debate on a lot of these technical issues has been made increasingly difficult simply by the lack of access to information. As you get less and less information, you're in a much poorer position to second-guess the national policies. Now, another problem, though, that runs deep is that the crazy changes in budgets that we've seen for crucial areas like energy efficiency have made it very, very tough for people to build careers in this field. Now, places like California have been the exception, where there really is a good market for people with skills in this area. But it's been very, very tough to get people to come into a field where the budgets change by 50% a year, depending on the political whim. And one of the things that Chuck Vest here is talking about is a proposal to set up what amounts to an energy advanced research projects agency that would be managed in a way that would be much more creative and open, that would attract a new generation of people. The dilemma here is that if they do that, it'll probably be by cutting programs in other areas, so that it's very difficult to separate the management issue from the budget. Now, the question I raised at the beginning is, do we have permission to actually try to do any of these things? And if you wonder why energy and the environment were virtually not mentioned in the previous election, it was that people looked at polls like this and said that, you know, people are interested in these issues, but it's way down their list. But of course, it depends on how you ask the question. One of the things that does keep popping up to the top of these lists is people are very concerned about the competitiveness of the U.S. economy. Are we staying abreast of the cutting edge that's required to create good jobs in the United States? I'll come back to that in a minute. This is something that Yale did. Of course, here, if you ask the right question, you end up with the right answer, but it's unfortunate global warming here is very close to the bottom, whereas dependence on oil and oil prices are high. Nonetheless, this is what I'm trying to do is provide some fodder on how we connect what it is we're doing to things that really are politically hot. Now, the interesting thing is that energy efficiency actually is extremely popular. When you ask people about it, it's strong, and actually people are more interested in efficiency than they are in new supplies. This is very good news. And it's, I'm sorry to tell you this, Art, that now that you're in the group that doesn't like efficiency here, so you have to be the, you have to hold up your end here. But this is another interesting Yale result, and that is it answers Bill Clinton's statement. You know, do you agree with the fact that you don't have to sacrifice environmental protection to get the economic growth? The choice between jobs and environment is a false one. We can have both. Well, here the most enthusiastic people are Republican men. Well, I guess men in general, but Republican men are way up there. So hidden in the country, there's a lot of enthusiasm for tech fixes and things where we actually can have it all. Now, whether that's possible or not, we can debate, but it's a real American passion. If you look at support for controversial things like fuel efficiency, you have to ask this extremely carefully. If you use mandates, command and control, jackbooted bureaucrats, you get one answer, you know. If you use regulation, efficiency, you get very positive results, even on something as controversial as a fuel economy standard. Now, one of the things that is roiling Washington right now is this huge debate about corruption. Interestingly enough, energy-related corruption is way up on the public's list. Now, the dilemma we've got here is that if you look at what's happening in the Washington energy policy debate this week, this issue has started to dominate the discussion, and you're ending up with really creative proposals in which the Republicans want to give everybody $100, which actually, and the Democrats are trying to give everybody relief from energy taxes. Now, if I had to choose, actually giving people the money, as you said, is probably better than cutting the price of energy, so because they're going to spend some of that money on, you know, going to the movies or something. But the debate has completely defocused into these weird sideshows. So let me get down to solutions. I mean, when you start looking at what you can actually do, first of all, you have, thanks to art and others here in California, an incredibly powerful track record to build on. Not only technically what you can do, but politically. You've got ideas that have survived Republican and Democratic administrations that are strongly supported. You've been able to maneuver through the minefields of public opinion and actually get things done. This is a tremendous opportunity to build on. So at the end, focusing on efficiency policy, it seems to me that we've got permission, in fact, eagerness from the public to put together an intelligent program in this area. What's clear is that efficiency is one of the things that, one of the very few places that has comparatively few downsides. Whatever you do, all of the new energy sources have tremendous liabilities and problems. The problems with energy efficiency, of course, is that it's maddeningly complicated. There are technologies that range from automobiles to light bulbs to industrial processes. You get into politics everywhere you go, and that if you can double fuel efficiency, but everybody lives twice as far from their jobs as they used to, you've undermined what you've done. If you double the efficiency of your furnace, but you live in a house that's 4 times larger, you've undermined what you're doing. All of these things are deeply involved in the politics of housing, property, transportation, and so on. And the other maddening thing about efficiency is that when you talk to economists, and here's my problem that we talked about from the business school, they all come in and say, it's trivial, you just raise the prices and everything will be all right. Well, no. And I think it just won't happen. And if you look at polling, it's just a disaster, however smart that may be. So what you're doing in efficiency is you're always living in the land of second best. And people hate that. You're trading off things that you know are not the most efficient way of proceeding. You're coming up with complex regulations, but that's where art has been brilliant, and I think California has been brilliant in trying to figure out how to come up with second and third tier ideas that actually work and actually contribute and make things happen. So here's at least where I come out on this. We do, in the next 2 elections, the one this year and the one 2 years from now, are going to have a crucial opportunity to figure out if we're going to fix this problem or make it worse. And I think the opportunity we've got is that we can, in fact, link the ideas of efficiency to the core idea of American competitiveness, innovation, and job creation, because it is true. I mean, General Motors said that making inefficient cars was a great way to run the company. They were wrong. International markets are moving in the direction of efficient, clever, well-engineered systems, and we've got a huge amount of runway in front of us on this. And there's always this concern we've somehow gotten all the low-hanging fruit, and we're running out of room to improve efficiency. Well, in fact, if you look at these systems, there's a huge amount of, I think I just gained 5 minutes, but and my existence proof is that you can operate one of the most sophisticated systems. If you look at biological systems, they're incredibly sophisticated systems, can operate close to room temperature renewably. In fact, something as sophisticated as Art Rosenfeld is today powered by a chicken taco, as I can testify directly. Now, so I think that there's a great opportunity there. The attention that we've gotten from gas prices puts this issue squarely on the horizon. And because of but we have to be clever. And one of the things that art has been very good at is understanding how efficiency fits into these broader schemes. One of the things we're working on now, for example, is something that by using improved composite materials, you can make it cheaper to build houses that are not only efficient, but also safer in earthquakes and hurricanes. And as a result, he's got good old boys from the Gulf Coast who probably would never have paid any attention to climate change, enthusiastically working with it. That's the kind of thing that I think actually can work. So the final point on this is the question of whether we can actually put an issue of values like climate change on the horizon. Again, I hope Joe talks about this. I know there's a lot of work. It seems to me that if we fail to do that, we are really going to fail to accomplish our overall goal. So I can just conclude here by saying that what art brings to the table here is an ability to search for technical solutions that make sense, engage in a public debate in an open and honest way that people respect, and create the kind of political dialogue that we desperately need and that can actually solve the problem. And I guess if Rob was going to end with a poem, I will, there's a famous Yeats poem about the best lacking all conviction, while the worst are full of passionate intensity. But I think with art, we've got the best with lots of conviction and lots of intensity, and thank you, Art.
Thank you. I wanted to ask a question about Steve Tabor. You mentioned that raising the price of energy is just a political non-starter. Let's assume for the moment that there were some mechanisms such as a carbon tax which had the effect of internalizing the externalities. Leading the worst possible outcome in that case, it would seem to me, would be that it would be a wealth transfer from the red states to the blue states. Why do you presume that's politically unsellable?
I am just using empirical data and repeated polling data. I'm not saying this is an unsolvable problem, but if there's somebody who's figured out a way to sell this, I don't know them. And every time you come even close to a vote on this, it goes down in flames. And it's exasperating. And everything you say is completely logical. Embedding the externalities into the price is the way you should do this. It turns out the public would far rather have complex regulations and other programs in place. One of my favorite art ideas that never got anywhere was the pay at the pump idea, for example, which I thought was a no-brainer. It made solid economic sense. Even that ran into a roadblock. So I don't know. I hate to be a pessimist on this, but rather than beat my head on that particular wall, I think we do need to focus on second and third best ideas that will work, and I think we've got a lot of opportunity space we haven't explored there. So the frustration is knowing that you're right, but the politics just don't seem to work.
Hi, Steve Scheller. I was wondering if you could follow up a little bit about the Chuck Vest quote you had about what kind of reaction you get to that in terms of funding, support for education of the sciences and education. And maybe a little bit in the context of the survey results that you put up there, they were very interesting. Personally, I take absolutely zero meaning from them because, frankly, I think the people who answer the phone, answer those, have absolutely no idea what they're talking about. So, unlike the rest of us who know exactly what we're talking about, of course. But so I wonder if you could talk a little bit about the reaction to science and engineering education and what we can do there. Okay. Thank you.
Well, first of all, on the polling, it scares the bejesus out of me, but politicians pay attention to these blasted polls and focus groups. And so I put that up there mostly so that you can see the world the way they're seeing it. If you're wondering the lenses through which somebody running for office with their consulting firms, how they think about things, that's what they're looking at. Now, in terms of education, I think that the inability to maintain a research infrastructure, which is in energy and related fields here, which should be about 2 or 3 times bigger than it is now. There are several problems. There are several disastrous problems. One is we're not getting the results, but second, we're not providing a way to train the generation of people we desperately need to attract to these kinds of problems. And if you can look at the kinds of problems we need to focus on, the reason that Vest was talking about this in part was that a lot of the most exciting stuff doesn't necessarily have energy written on it, but there might be somebody working on nanotech or controls or a biological process, which has a huge order of magnitude effect on energy if they were able to be paid to try to transfer what they know into energy. So I actually think that Vest, I dug that Vest quote out of a huge obscure hearing. I think we can get a lot of traction with that. I think that the one thing that we can get huge agreement on is that we need to have a solid research base, and people keep on talking about having an Apollo program. But the thing that we can't do without is getting a lot of smart people who are able to build their careers around research in this area. And the funding of the students, the graduate students, the postdocs that you need to make that happen needs to be continuous, and it needs to be 2 or 3 times bigger than it is now. And I think that actually has some political legs.
Yeah, Steve Nadell, ACAAA. Henry, as you know, I also do a lot of work in Washington, and I agree with you. There are many senior policymakers who have decided for philosophical or other reasons what they want and really dismiss the science. There are many people who do care, and I think one of the things we all need to do together is to work with them, encourage them, and stretch the number of people who do care. Getting involved in some of the training programs for entering, congressional representatives, visiting the staff. A lot of this, frankly, is retail, and it means needing the shoe leather, whether it's from the universities in their districts or, National Academy or other people visiting their offices. They don't generally have time for these big hearings. They don't even show up for them most of the part, but get to meet with the staff and encourage them, bring them the results. It's a lot of effort, but I think there's some opportunities there, and I was curious what you think about that.
Oh, I completely agree, and I think NGOs have a real opportunity. One of the problems that the academies have is that it's very hard for them to testify because they can't get off of the precise conclusions of the report. And I guess John is probably more expert on this than anyone around here. But that has been one of the dilemmas, is to get some of the really fine work that's been done by the academies and others delivered to the Hill in an efficient way. And that's one of the things that NGOs can do. And if you can have John showing up not as the Academy spokesman, but as a Harvard professor, that's often more effective. And
we'll take one more question and then.
B.B. Blevins, California Energy Commission. A lot of your presentation involves public perception, and the mass media has a great deal to say about public perception. I was wondering, I guess my polite question is, could you comment on the interrelationship currently between organizations like yourself and the modern media? And my impolite question is, are you going to start organizing yourselves better in order to counter the modern media?
Well, one of the problems, of course, is exactly what is the modern media. And a major concern of ours has been some of the people that we've relied on the most to really get to do science writing correct have been major newspapers. Newspapers are in real trouble. The economic base is being eaten by people who are, Craigslist and other things. Their revenues are down. I think readership went down 6% in the last year. So they're having a real problem. And one of the things that they do when they're looking around for things to cut is they're cutting their science writers. Dallas Morning News laid off their entire science writer staff as a cost-cutting measure. Now, the New York Times is one of the few groups that's been able to hold on, but it's a huge problem for them. So instead of newspapers, what you've got is TV news, and of course, it's a lot cheaper to hire some talking head with wild opinions than actually hire a fairly expensive science writer guy who actually goes off and spends 2 days doing some research and putting a story together. Now, the new media that is interesting, of course, is that you can now read publications from the California Energy Commission and Berkeley by Googling. I don't know who wins in this game. I hope to God that people who are entering this new media, getting their RSS feeds and their podcasts and so on, are getting a more diverse set of information. But without a filter, it's a little scary. It's hard to know what the net impact of this massive change in the way people get information is going to have on this debate.